Good morning. My name is Bryson Robertson, and I'm here on behalf of the Pacific Marine Energy Center to talk about marine energy in Oregon. How do renewable energy pathway and the blue economy, and how are they applied in Oregon? I'm delighted to be here. Thank you so much to State of the Coast for pulling together this virtual conference, and looking forward to all the talks and presentations. So as we move forward, I think it's important to start here. The past does not represent the future. I think this is immediately evident to those folks at the conference, but it does bear repeating. Firstly, I think it draws that we can no longer continue to do things the same way we have done in the past and expect a different result. We need to draw a new path towards sustainability in the future. We can't lean on our processes, tools, methods to move forward. We need to continually reassess, rethink, and redevelop so we can mitigate the worst impacts of climate change. So what is climate change going to do to us? This is from NOAA. I pulled this off the NOAA website. What is in the Pacific Northwest? What do we expect? This is a fairly scary looking text. So we're looking at reduced stream flow. For competing demands, we're looking at sea level rise, erosion, inundation, risk to infrastructure, increasing ocean acidity, wildfire, insect outbreaks, tree diseases. That's not a pretty picture. So we need to do something about this. Climate change is the major driving factor why we cannot continue to do things the same way as we did in the past. We really need to change it. So when we're looking at climate change, and we're going to understand that it's generally driven by emissions, human-based emissions, how do we get after this? And on the left here, we have where CO2 emissions in the US generally come from. And you see predominantly it's from energy for electricity and heat, energy for transportation, energy for manufacturing, and energy for fuel combustion. So if we're focused on developing new tools, new processes, new methods to get after these things, to plot a new path towards sustainability, we need to deal with our energy issues. So we're focused in its energy, and we need to go after heat and electricity. So this is a great paper from 2015. It's dated now, but it still shows the right way. The most plausible way forward is to reduce global CO2 emissions is to increase the role of very low carbon technologies in electricity generation, and to increase the use of heating in increase the use of electricity in transportation and heating. So let's put that in a simpler way. Step one, we need to increase the amount of renewable electricity generation. Step two, we need to use that new electricity to substitute fossil fuels in transportation and heating. So that's fantastic. We need to make lots of electricity. We need to make it renewable. So if we're looking forward to 2015, this is what the IEA, the International Energy Association, is predicting. We're going to see huge increases in solar and wind. We're going to see some increases in offshore wind. Hydropower is going to be there, but there's still this big chunk in the lower right here where gas-fired, oil-fired, coal-fired is still a huge part of our electricity generation, but we need to change that. And this is where there's a significant opportunity for wave, tidal, offshore wind, other sort of ocean-based renewable electricity. So what are the types of electricity generation technologies, from waves, at least, that we're looking at? So one is, on the far left, is Polaris, which is deployed of Portugal in that picture. And it generates electricity by, as the waves pass, you get this sort of sausage that rotates. And at this joint is where we can generate electricity. Resolute Marine Energy, which is in the middle left, generates electricity by the back and forth surge of the wave energy device in the shallow water. Sea Power, which is a local Corvallis company, generates electricity from the changing elevation of the sea surface as waves pass by. On the far right, we have a neat Scandinavian technology where as the raft of the technology rotates, we get this pendulum effect. We can get a heavy pendulum to start spinning. We can generate electricity from that. And these aren't all just concepts and things we sort of have on the back of napkins and engineering paper, but they actually are getting built. This is the Ocean Energy Limited technology getting built in Portland last summer. The buoy is currently in Hawaii, waiting deployment at the Wave Energy Test Site. But this is just to show that we are actually building these technologies. We are moving forward slowly, but we're trying to do it in the most responsible way forward. I'll leave this in my slide deck for people to watch, but I'm not going to get too further into it in this presentation. So what are we doing in the Pacific Northwest? So the Pacific Marine Energy Center, where I help direct, is really leading the academic effort in this space. And it's a collaboration between the University of Alaska Fairbanks, the University of Washington, and Oregon State University to responsibly advance marine energy by expanding scientific understanding, engaging stakeholders, and educating the workforce of tomorrow. So sort of three major goals of the center: expanding understanding, engaging stakeholders, and educating the workforce of tomorrow. And I like to say we have the benefit in PMAC of being a mile wide and a mile deep, because we can leverage the incredible minds, the incredible enthusiasm and inquisitive nature of faculty members, students, research associates at these three world-class universities. And we can go after the technical challenges, the environmental challenges, the social challenges, or opportunities as we develop the sector. So whether it's looking at survivability and reliability of devices, or the impact on benthic ecosystems, or what does the energy policy or the existing ocean users in the social space, how do these all work together to do that responsible advancement of the sector? So at OSU, we have some incredible facilities. For those of you who've been on campus, you may have seen the OH Hinsdale Wave Research Laboratory. So this is where we take designs from background envelopes, sort of napkins thing, and we try and test them out. We try and optimize them. You build them small, you can put them in the tank, we can push waves towards it, and we can start to understand how is the system going to work? Does it have significant potential? Hatfield does an incredible environmental and ocean monitoring work for us to support the development sector. That's Dr. Sarah Henkel, about to head out to sea to understand the benthic ecosystem and how might marine energy have an impact there. PacWave we'll get into in the next slide, but it's the new big shiny thing on the coast. Finally, on the right, we have the Wallace Energy Systems and Renewables Facility. And this is where we can start to look at, once we start to put electric vehicles, electric heat, wind, solar, wave, all these different technologies into the mixing pot, which is our electricity grid, can we make sure it's reliable, it's cheap, it's efficient, and it's safe? So that's where we do sort of that final integration part. So PacWave, I know many people have heard about it over the last few years. Grid, two sites, a north side of Queen Head and a south side, which is a 20 megawatt grid connected test facilities. Focus on tests. These are not commercial development opportunities. These are where companies can come and do their testing to prove out their devices before they go to market. It's a fantastic opportunity for the US. This will be the biggest non-European test facility in the world, which is amazing for us to have right on the coast here. So when we start to understand, yes, we deal with a lot of technical challenges, we start to understand the environment, but we need to understand what the social context of developing this. So in the spring, we had some researchers look and do a survey of California, Oregon, Washington, British Columbia, trying to understand how do people on the coast feel about this. On the left here, you see wave highlights. And I think the one thing that jumps out for me is one incredible sort of agreement that we need to start to use, generate more wave energy. Two, that there are very few people opposed to it. Of all of the generation technologies, wave is the least or the one that people want to see us reduce the least. On the right-hand side, similar, but we showed that there's support across the political spectrum to see us start to do this, which again is a great opportunity for us to start to move forward. But as we start to look at this in the broader context, what else can we do with wave energy? Rather than just powering electrical grids on land, what else can we do in the deep ocean, this big blue expanse that even on Google Earth, where we normally have all the information we ever want, it's just blue, and we don't understand much about it. So one of the things we're doing at PMAC and across the whole sector is trying to say, where does marine energy hold a unique value proposition to meet the energy needs of a sustainable blue economy? So as we start to sort of look to our oceans to new ways to generate economic growth, how can we do it in a sustainable way? And how can we use marine energy to help facilitate that? Now, whether that's ocean observing, whether that's vehicle charging, whether it's desalination or disaster response, or even seawater mining, how can we do this in a sustainable manner? And what's the role of marine energy as we move forward? Again, this is where we have so much great engagement with our students and our faculty members. In the top left, we have the Marine Energy Collegiate Competition. We have a group of students looking at developing a wave energy device to power ocean observing. There will be a presentation that later today. I do encourage people to see it. On the lower left, we have the Wave to Water Prize, where we had a group of students and faculty members looking to develop a technology to use wave energy to desalinate water, so we can start to provide water, which is a basic human need to many places around the world. On the right, we have another group of students and faculty members starting to look, can we design wave energy devices to power underwater vehicles that can then map the seafloor so we understand what's happening down there? We can We can measure new changes in the ocean, whether it's red tide or the chemical changes. Can we develop devices that follow that change, all powered with sustainable energy? So again, coming back to the beginning, the past does not represent the future. And generally, this is kind of put in the context of, and here lies the challenge. But I'd like to switch that around and say, and herein lies the opportunity. Now we can develop new tools, new processes that can make sure the way we move forward and the way we develop our oceans and use our oceans is in a sustainable, well thought out process. So here are my details. I encourage people to reach out, send me an email. I'm here for questions, and I'm really delighted and excited for the rest of the conference. Thank you so much.